Okay, so this video is about speed, velocity and momentum, and these are level 1 questions. So the first question is about a floating toy, and it asks you to calculate the weight. Okay, so remember, weight is equal to mass times gravity. So the mass in this question is 0.06 kilograms. We're going to multiply that by 10, and that will give us our weight, which is 0.6 newtons. Okay, when the toy is hovering stationary in midair, the lift force is. So remember, when anything is stationary, it's at a constant speed, so the forces must be balanced. So the lift force is the same as the weight of the toy. Remember, this is the weight and this is the lift force pushing up. When the motor inside the toy is switched off, the toy starts to accelerate downwards. What does accelerate mean? Accelerate is a change in velocity. Okay, and remember, a change in velocity could be, because velocity is a vector, could mean a change in speed or a change in direction. What is the direction of the resultant force on the falling toy? Well, that would be downwards. Okay, remember, objects always accelerate in the direction of the force. So if it's accelerating downwards, the resultant force must be downwards. Okay, this next question says, what was the distance of the race? Well, that's from the start to finish, so you can see the finish is there, and that is a distance of 60 kilometers. So that's the distance there. How long did it take the horse and rider to complete the race? Well, that's this point here, so that is 5.5 hours. What distance did the horse and rider travel in the first 2 hours of the race? So we go to 2, and up from 2 is there. Okay, so that gives us a distance of 30 kilometers. Okay, how long did the horse and rider stop and rest during the race? Well, the rest point will be a flat point on a distance time graph, so that's between B and C. So how long is that? That is 30 minutes or half an hour. Okay, the next question, not counting the time it was rested, which we just discussed, between which 2 points was the horse moving the slowest? So we're looking for any gradient. It's the shallowest gradient, the least steep. And clearly this area here is the least steep part of the graph, so that's between D and E. So give a reason, as we just said, gradient is least steep. And remember, the gradient is just this line on the graph, so the gradient there is the least steep. Okay, moving on to the next question. Which one of the following statements describes the motion of the person between points R and S? So remember, they are not moving. You could argue that they're moving at a constant speed, and the constant speed is 0 meters per second, but the most relevant answer is not moving. Another person walking at a constant speed travels the same distance to the bus stop in 200. Okay, so in 200 seconds, we're going to put a point there. This is where we're going to aim for. And at a constant speed means it's just a straight line. So with a ruler, you would need to make sure you join those points up. Make sure you do this with a pencil and a ruler. Okay, the next question is about resultant force. Our resultant force is going to be equal to the mass of an object times its acceleration. The mass is 14,000. I'm going to times that by the acceleration, which is 2.5 meters per second squared. Okay, and that gives us 35,000 newtons. Okay, this is about stopping distance. Remember, stopping distance is the thinking distance and the braking distance. So the stopping distance is found by adding the distance the car travels during the driver's reaction time. Okay, so that's from seeing someone to actually pressing the brakes, and the distance the car travels under the braking force. Okay, so that's from applying the brakes to actually stopping. So stopping is the whole thing, the thinking and the braking distance combined. Okay, which one of the following would not increase the thinking distance? Well, that's the car tyres being badly worn. That's only to do with the braking distance, because that affects how, from pressing the brakes to how much distance is travelled before the car stops. Okay, what conclusion about braking distance can be made from the graph? Well, we can clearly see that as you increase the speed, the braking distance increases. But this is not a proportional relationship, okay, because we have a curve here. So you would need to say that as the speed increases, the braking distance increases, and this is not proportional, okay? So increasing speed increases braking distance, okay, and this is not proportional as a greater speed has a larger effect on braking distance. Okay, now the next question asks us to draw a line on the graph to show what is likely to happen to the braking distance at different speeds if the car was driven on an icy road. Well, if we were to give an example, we would know that on an icy road, if we were going 10 meters per second, it would take longer to brake. So it would be somewhere like this. Just put a little point here. And if we were going 20 meters per second, it would take much longer to brake as well. So we know that this line is probably going to look something like that. Okay, it's going to take longer to brake and stop at a higher speed. So the line needs to sit above the line that was already there. Okay, the next question. A local newspaper reported that a councillor said it will be much safer because drivers can react much faster when driving at 20 miles per hour than when driving at 30 miles per hour. The statement is wrong. Why is this? Okay, the reason for that is reaction time is not affected by the speed of a car. Okay, the only thing that's going to affect your reaction time is if you're distracted, if you've taken drugs, alcohol, if you're tired. That will affect your reaction time, not how fast the car is going. The local council must decide whether to introduce lower speed limits on a lot more roads. What evidence should the local council collect to help make this decision? Well, the first thing they need to do is they need to know the number of accidents at different speed limits. So, number of accidents at different speed limits. Okay? And what they would be looking for is if there are less accidents on the roads that have lower speed limits, then that would point to evidence suggesting there's a correlation between low speed and low accidents. So if there is less accidents on lower speed roads, then evidence suggests councillor is correct. Okay, so that's really important. You're looking for evidence. If the evidence supports his claim, then it's backed up. If the evidence doesn't support his claim, then it doesn't back it up. And that's all you need to talk about. In questions like this, it's looking for the evidence. Okay, student B closes her hand the moment she sees the ruler fall. This investigation can be used to find out if listening to music changes the reaction times of a student. Explain how. Okay, so in this particular question, we're going to carry out two tests. So we're going to carry out ruler test without music. Okay, So you need to suggest how to do that. So I'm just going to briefly describe it but not write that down. So they're going to drop the ruler and they're going to see the reaction time without the music. They're then going to do this a few more times, maybe carry out, so we'll say carry out test 5 times and get an average. Okay? You're then going to do the test with music. So you do exactly the same, but you need to write this out and be specific. Exactly the same with music. Then you will have another mean that you've calculated from the 5 tests, and you can compare the average. So you can compare the average without the music and with the music, and then you can see if the music has had an effect. And the bigger the sample size, the more reliable your data. So if you did it with 10 tests or 15 tests, then you're going to get a more reliable answer. Okay, in this next question, give one conclusion that can be made from the results for student X and for student Y. Okay, so you can see for student X, we look at the whole set of results, 0.44, 0.4, 0.34. So X, improved reaction time as she carried out more tests. Okay, so what that's saying is the first time they were quite slow, but by doing it again they got better, and the third time they got even better still. So it's trying to suggest that actually practice has made this person better. Test 3 for student Z gave an anomalous result. So you can clearly see that Z has got 0.36, 0.33. We would expect it to get better, but actually they've got worse, so this is an anomalous result. Suggest 2 possible reasons why this anomalous result might have occurred. Well, remember we talked about this idea before here, that the thing that affects reaction time could be distractions. Okay, so maybe they were distracted, or there could be an error timing. Now, generally with human error, the main human error is timing. So if it's anything to do with a stopwatch, you could talk about human error. Okay, so the person didn't start and stop the stopwatch correctly. Right, some students designed and built an electric-powered go-kart. The go-kart is shown below. Suggests 2 changes that could be made to the design of the go-kart to increase its speed. Okay, so what you could do is you could have a lower mass. So instead of having a mass of 100 kilograms, it could have a mass of 70 kilograms, and that would affect its top speed. Another thing is this pointy shape, so we could make it more, we call it aerodynamic, okay, which means it cuts through the air better, so it's going to have lower air resistance and therefore a higher top speed, because less air particles are going to hit it and therefore slow it down. Okay, so this next graph is going to be related to our next question. It says a go-kart with a new design is entering into a race. The velocity time graph for the go-kart during the first 40 seconds of the race is shown below. So the whole thing takes 40 seconds. And the first question says, between which 2 points did the go-kart have the greatest acceleration? So we're looking for the steepest part, and the steepest part is clearly between A and B. So we're going to give that. And again, we're going to say it is the steepest gradient. Remember, the gradient is the line on the graph. Okay, the go-kart travels at a speed of 13 meters per second between points D and E. The total mass of the go-kart and driver is 140 kilograms. We're going to calculate the momentum here. So remember, momentum is given the letter P, and it's equal to mass times velocity, and that's equal to a mass of 140. We're going to multiply that by the velocity, which is 13, and that gives us a momentum of 1,820 kilogram meters per second. Remember, mass is in kilograms and speed is in, or velocity is in meters per second, so they're the units put together. Okay, after falling from the aircraft, a skydiver reached a steady speed of 373 meters per second after 632 seconds. So this is the world record velocity for skydiving. Draw a ring around the correct statement to complete this sentence. The maximum steady velocity is called the something velocity. Remember, this is called the terminal velocity. The skydiver wore a chest pack containing monitoring and tracking equipment. The weight of the chest pack was 54 newtons. The gravitational field strength is 10 newtons per kilogram. Calculate the mass of the chest pack. Okay, so we know that weight is equal to mass times gravity. We've done this equation a lot now. So we rearrange this equation. Mass is going to be equal to weight divided by the gravity, and therefore that's equal to 54 divided by 10, and that's going to give you a mass of 5.4 kilograms. Okay, in this question, during his fall, the skydiver's accelerate was not uniform. Immediately after leaving the aircraft, the skydiver's acceleration was 10 meters per second squared. Without any calculation, estimate his acceleration a few seconds after leaving the aircraft. Explain your value of acceleration in terms of forces. So it's going to be less, okay, and the reason for that is because there's going to be some air resistance. So therefore, we'll say 7 meters per second squared, but you can pick a number that's below 10. Okay, and the reason for this is as he falls, the air resistance is going to increase. So as he falls, air, we'll just put R for resistance, increases. Okay, gravity, G, is constant. Okay, and if gravity is constant, the acceleration must decrease as the overall resultant force is going to go down. So if we've got gravity pulling down and that's constant, when he starts, there is very little air resistance. We'll say no air resistance, so he falls at 10 meters per second squared. As he keeps falling, the G is constant, but his air resistance is going to increase. And eventually, they're going to be the same. But as he's accelerating, we'll be at this point here, so you can see that air resistance, this arrow pushing up, has increased, gravity is constant, and therefore the resultant force is going to be less. Okay, so this resultant overall force of this vector will be less because gravity is having to counteract the resistive force. Without any calculation, estimate his acceleration 632 seconds after leaving the aircraft. Explain your value of acceleration in terms of forces. So at 632, we set it at a steady velocity. Steady velocity, remember, means constant velocity, and that means the forces have to be the same. If the forces are the same, you get no acceleration. They will travel at a constant speed. So the estimate would be 0 meters per second squared acceleration. And the reason for that is because the skydiver is traveling at a constant speed. Okay? And if you travel at a constant speed, that is because the forces are balanced, therefore there is, so I'll put therefore, no acceleration. Okay? Due to 0 resultant force. You must always talk about the lack of a resultant force. So if the forces are balanced, there is no resultant force. And that's because the force pulling down, we'll just call it 10, and the force pushing up is 10. So the resultant force is 10 minus 10 is 0 newtons. Okay, no resultant force. Okay, in the next question, a car moving at a steady speed has a driving force of 3,000 newtons. So we've just talked about this steady speed. If the steady speed, it means whatever the force is pushing one way, it must be the same pushing the other. So the resistive force, the friction, the air resistance combined must equal 3,000 newtons. What causes most of the resistive force? It's going to be air resistance in a car. Okay, the next question. A car is moving along a road. The driver sees an obstacle in the road at time t equals 0. So this is when they've seen the obstacle. Okay, and you can see they're going at a particular velocity and they're continuing to go at that velocity until they press the brakes, and then they're slowing down, and here they've stopped. So what feature of the graph represents the negative acceleration of the car? That is going to be the gradient. So this gradient here represents the negative acceleration, the slowing down, because they've gone from a velocity here Let's make this velocity up and say it's 10 to a velocity here which is 0. So they've gone from 10 to 0, they've slowed down. Which feature of the graph represents the distance travelled by the car? That is the area. So if you were to calculate the area, that would be the distance travelled. Okay, so that is the area under the graph. Okay, on a different journey, the car is moving at a greater steady speed. The driver sees an obstacle in the time at time 0, so that's the same start, and applies the brakes until the car stops. The driver's reaction time and braking distance are the same as shown in the graph above. On the graph above, which is this graph here, draw another graph to show the motion of the car. So it's starting at the same point. Okay, it's going at a greater steady speed, which means a constant velocity, and the driver's reaction time and the braking distance are the same. So overall, it must stop at the same point. So it has to stop here. Okay, we know it has to stop at that point, and we know it has to start on this line, but at a greater speed. So it says at a greater constant speed to here. So the driver sees an obstacle in the road at time t0 and applies the brakes until the car stops. Okay, the driver's reaction time and braking distance. So the reaction time is here to here. So this is the same. We know they are the same. Okay, and the braking distance is the same. Now, that means the distance is the same. So if they're going faster at this point, then they're going to have to stop at a sooner time because they're going to cover more distance because they're going faster. So somewhere before here is going to stop, okay? So it's really important that you recognize that he's not going to stop at the same point because they've covered a larger distance in a shorter period of time. The reason for that is they are going a faster velocity. So if they're going 15 meters per second when they press the brakes, in order to cover the same amount of distance, they'd have to stop faster. Okay, so that's a bit of a tough question. You really have to think that one through. The next question, it says, thinking distance and braking distance affect stopping distance. Explain how the factors that affect thinking distance and braking distance affect stopping distance. So the first thing is, let's explain what stopping distance is. So stopping distance, now remember when you do this, you need to do it in bullet points and you need to make each thing a specific sentence. So it's looking for good quality written communication. So write in sentences and bullet point the points. So stopping distance is equal to the thinking plus the braking distance. Okay, so you need to write that start of all, opening sentence, explain what stopping distance means. And then you need to talk about the things that are going to increase either. So we'll talk about both. So the thing that's going to increase both thinking and braking is the velocity. If you have the car moving faster, it will travel further while you're thinking about pressing the brakes, and it will travel further when pressing the brakes to actually stopping. So that affects both. Now we're going to talk about just thinking distance. So what's going to affect the thinking distance? Well, I'm just going to list them, and you need to put this into sentences when you're doing this so it's in good written communication. So the thinking distance, explain what it is the distance travelled by driver whilst reacting to object in front of them. Okay, so from actually seeing something to pressing the brakes, that is the thinking distance. So what's going to affect that? The main factors are tiredness, drugs, alcohol, and also distractions. Okay, but you could argue this last one, so I put that last. In terms of braking distance, it is the distance travelled by a driver from pressing brakes to actually stopping. Okay, so it is the distance travelled. Don't say the time taken. They are both the distance travelled from pressing the brakes to actually stopping. And the factors that are going to affect this, we've talked about velocity. Other ones are quality of brakes. Some cars have much better brakes than others. Okay, road conditions, but be specific. So road conditions, and then you need to say icy or wet, and tire tread. Okay, and that is in wet conditions. Sorry about the handwriting, but you understand what I mean. So if you put all of that into some good written communication, remember bullet point it, specific sentences, you're going to get full marks for including that amount of detail. Okay, so I've finished all of the level 1 questions. I'm now going to put all the answers on, just so you can pause it if you went straight to the answers at the end.